Hello and welcome to this video about determinant proofs. In this video we'll explore this theorem that extends the theorems that we proved before from rows to columns. We'll do this by using theorem D.1, but it doesn't automatically just extend these theorems to columns. Theorem D.1 has to be embedded in a well-constructed proof so as to prove this theorem properly, not just refer to it. So here's a sample of some of these theorems that we'll be extending from rows to columns using the determinant transpose theorem. So now to start with the first theorem, that swapping two columns in a matrix multiplies the determinant by -1. I could have put this directly in the second video, but I thought it would be better to separate it out because it was too much to take in all at once. I thought it was a good idea to gather all of these column proofs together into one video. Now to start this proof, we'll start with matrix B that has its columns swapped with respect to A. We'll set its determinant equal to the determinant of its transpose. We can invoke this pass theorem to do this. Now we can invoke this theorem because the transpose of B has its rows swapped with respect to A. So we can invoke this pass theorem to get this equality. Then we can invoke the determinant transpose theorem again to get minus the determinant of A. So we've proven part A. But we needed to construct some sort of proof around the determinant transpose theorem. Now to prove part B, that a matrix that has identical columns has a determinant of 0. We can invoke this determinant transpose theorem to get this result. Then we can invoke this corollary because transpose A has two identical rows. And that's it. We've proven this matrix to have a determinant of 0. Now to prove part C. It's the column mul operation, where a column is multiplied by a constant, and its determinant should be multiplied by this constant. So now we'll start this proof. We'll use this theorem first again. We can invoke this theorem about the row mul operation. Then we can use the transpose theorem to get us back to this line, which proves this theorem. It's a simple theorem, but it still needs to be constructed properly. Now to prove this zero column proof. I guess you might be getting used to this style of proof, and you might like to pause this video and guess the proof. We'll firstly invoke this theorem like we did in the past three parts of this theorem. And it's 0 because the transpose of A obviously has a 0 row. Here's the column add operation theorem. Adding a multiple of one column to another doesn't change the determinant. We'll start with this theorem like we did before. Now we can invoke the row add theorem to get this equality, which gives us this. So we've proven this theorem for column add operations fairly quickly, and I hope predictably. Now to prove this volume theorem for when the vectors are columns instead of rows. So now to start this proof, we'll set matrix A to be this matrix with columns of these vectors. We'll invoke this theorem again. It should work for the absolute value function because this function subtracts information. If it needed extra information, then it couldn't be used like this in a proof. And the transpose of A consists of row vectors of V and should give the volume according to this pass theorem. And here's a picture of A transpose made up of row vectors of V that we've proven it for. And finally, this last theorem about these three matrices that are identical except for one column, so that one of matrix A's columns is the sum of the columns of the other two matrices. We've proven it for rows, now we have to prove it for columns. This statement is true because this time it's the rows that obey this sum rule. And we can easily substitute these matrices in for the transposes of these matrices, thereby completing this part of the theorem in only 2 steps. So we've proven the whole theorem. So I hope that you found this video to be helpful and educational, and I hope that you thought it was a good idea to make a special video about proving these theorems for columns gathered together into one video. If you like this video, please click like and subscribe. Feel free to write anything helpful in the comments and to share this video, and thanks a lot for watching.